Today we are going to see about logic gates in semiconductor chapters. What are the logic gates and some of the important logic gates how you can solve with the help of Boolean algebra, and some of the truth table for different types of gates that we are going to see in this chapter. Okay, now this one already told the weightages of a semiconductor chapter in NEET and EAMCET program. One of the important gate here is not gate. See here, input this side here is you are having input and this side you are going to have an output. If see in logic gates we are having binary digits 0 or 1. In this case a binary digit 0 we call it as switch off, 1 we call it as switch on. Input will be given as 0 and output what you are getting here is a complementary of input, that is 1. So if you are going to give as an input 0, output you are going to get 1. If you are going to give 1 as an input, 0 as an output. See for this one, what is the Boolean expression in this case here is I just mentioned here. For this one, y is equal to a bar. This is about the complementary. A bar is the complementary. Suppose we are going to give 0 as an input, 0 bar here is 1. 1 as an input, 1 bar here is 0. That is an output. Okay. Next one here is AND gate. See in this AND gate you are having two input and one output. See especially in case of logic gates you are having one, two or more input will be there, but output should be only one. This concept you just remember here. This is the basic thing in case of logic gate. You are having one, two or more input or only one output should be there in this case. See in this case, what is the AND gate of Boolean algebra I just mentioned here. In this case, y is equal to, see here, y is equal to a dot b. Now this one, see here I just mentioned here in this case, see this one, this is a and this is b, input 1 and input 2. So this one a and b I just mentioned here, 0 dot 0, what you are going to have here is 0 dot 0 here is 0, 0 dot 1 is again 0, 1 dot 0 here is 0, 1 dot 1 is 1. So from this one, uh, 0 means both the input is 0 means output also 0. Any one of the input is 1, so you are getting that output is always 0. If both the input is 1 here is output what you are getting here is 1 now. Okay, next one. This is about NAND gate. NAND gate is nothing but simple AND gate with the NOT gate. See I just mentioned here, I just mentioned this one, AND gate plus NOT gate, that we are mentioning here as NAND gate. See already we have seen this one in case of AND gate. See that input here is 0 dot 0, what you are getting here is 0, and 1 dot 0, everything will be 0 0 will be there in the previous one. See this one 0 dot 1 here is 0 and 1 dot 1 here is 1 plus NOT gate. This is about the complementary you are going to have. So this will be given as an input here for the NOT gate. See here, this is about NOT gate here. Once you are going to give 0 as an input, what you are getting here is output is 1. Similarly, 0 is an input, what you are getting here is output is 1. Similarly, the third one, 0 complementary here is 1 and 1 complementary here is 0. So this concept can be used here. See, this one, the same concept will be given here, 0 0. This is the input and output what you are getting here is 1. So NOT gate simple here, AND gate plus NOT gate, that is NAND gate. Okay. Next one, similar concept in case of OR gate. OR gate here is A plus B. See, both in any one of the input is 1, output should be 1. If both the input is 0, that time only output is 0. See, this one I just mentioned here. In this case, what is the Boolean expression? Here is y is equal to A plus B. Now this one you just mentioned here, a plus b, that is about the Boolean expression here. 0 plus 0 is 0, 0 plus 1 is 1, 1 plus 0 is 1, 1 plus 1 is 1. See here, this one I just explained here, some Boolean expression here. So that you can understand here, see 1, see in this case you just mentioned here, 0 plus 0 will be 0 and 1 plus 0 or even 0 plus 1 will be 1. And in case of binary addition, in this case 1 plus 1 here is usually, this is binary addition, 1 plus 1 is 10. Again you just add this one, 1 plus 0 again 1. This is binary addition. See, you are going to use only the input 0 or 1 only, not any other numbers. In this case, see here, 1 plus 1 is 10. And even again if I mention here, see this one again I just mentioned in this case. See here, 10 plus 1 here is 11, right? And here again if you are mentioning this one, 1 plus 1 here is 10 again here, and 10 here is 1 plus 0 again you can mention here is 1. So whatever it may be, see 1 plus 1, or even if you consider as 11, 1 plus 0 here, see even you just mention here, or 0 plus 1, see you can mention this one 0 0 1 1 0 1 1. See these and all as an input. See in this case I just mentioned here, the next one I just tell you. So this is about R gate. To understand better about the truth table and truth table input, I just tell you some of the important topic, important concept. Just go through on this. See, for the case of truth table, I just mentioned here, what are the input will be given as, the first one will be given as two input here is 0 0 and 0 1 1 0 and 1 1. This one I just mentioned in this case. For 0 you can mention here binary digit 0 0. For 1 you can mention this one as binary digit is 0 1. For the 2 again here it's like this. For the 3 it will be like this. How you can convert this one, the normal numerical number, into a binary function. See, this is about the binary function. You can read this one in case of computer science. You can understand here 0 0 you just mentioned here 0 and 0. This is 2 bit. See here, this is 2 bit. Or in case of a 4 bit, how you can mention here is 4 bit 0 here is, see there are a 4 bit 0 0 0 0. This is about the electronics. For the 1 you can mention here 0 0 1 0, sorry 0 1, I'm sorry. In this case I just mentioned here, this one here is, this one I just mentioned here, this one here is 0 1, and 4 bit here is 0 0 1 0, and a 5, this one 4 bit. For the number 3 here is 0 0 1 1. See here how you are converting. This is 2 bit system, 2 bit binary system. This one here is 4 bit. How you are getting this one, this is about the analog values or even numerical values into a binary system. Say for example any binary system you just mentioned here, for example 1 I just mentioned here, 2, right? This one here is not divisible, so balance here is 1. Like this you have to write down 0 1. In case of 2 I just mentioned here, 2 here is, you just everything you just divide it as by 2. See here is 1 times, balance here is 0, you just mention like this. Next one similar like this. In case of 3 I just mentioned 1, balance here is 1, I just mentioned here. Suppose in case of 4, similar concept. See here 2, 2 times of this one, balance here is 0, again I just mentioned here 2, 1 times here is, balance here is 0, so you just mention as this one. So here in this case for the 4, see here for the 4 how you can mention here is, see this one I just mentioned in this case, this one is 0 1 2 3, and the fourth one here is, see here 0 1 0 0. This is fourth one. See from this one you can understand here, for fourth bit you just mention here 0. Next one fifth, this is fifth here is, I just mentioned here 0 1 0 1. See how you can get this value here is, take 5 here and divided by 2. What you are getting here is 2 times, balance here is 1. So again 2 divided by 2, so this is 1 time, balance here is 0. So like this you have to write down here. See from this one 1 0 1. Okay, now this is the concept. The previous one I told 0 plus 1 here is 1, 1 plus 1 here is 10, and even 10 plus 1 here is 11. So this concept from this one, see 1, this is 1, 1 plus 1 is 2, right? This is 1 plus 1 is 2, 2 plus 1 is 3, like that. One value here is 0 0 0 1. See similar concept, this one I just mentioned here, this one I just mentioned here. In this case see 0 0 0 1. Again 1 plus 1 is 0, right? 0 0 0 1. 1 plus 1 is 10, 0. Balance here is 1. Again I just mentioned here 0 0 1 0. So second came. Similar concept, 4 plus 1. See here the same concept I just mentioned here. Fourth value here is 0 1 0 0 plus 1 0 0 0 1. So what you are getting here is 0 1 0 1. This value for 5. Similar like this you just mentioned here in case of a sixth one. Sixth one I just mentioned here 6, like a second table, 3 times of balance here is 0, again 2, 1 times balance here is 1, like this you just mentioned here. See from this one what you are having here is 1 1 0. Here is 4 digits, so the last one is 0 now. So 1 1 0, what you got? See 5 plus 1 I just mentioned here in this case 0 1 0 1. One value here is 0 1. You just had here 1 plus 1 is 10, 0 balance here is 1, again 1 is came here. This 1 plus 0, again 1 0. So this way you can get the all binary addition. This is the input has been given to the next slide. See here truth table. Okay, now Boolean algebra. See here, one is about the truth table. We have seen the previous one. Now we'll see about the Boolean algebra. See here, the same concept. 0 1 multiplied with the input. See here, identity means the same value. Anything you multiply with 1, what you are getting here is a. And R here is identity. This is 0 function. 0 plus a here is a. And this one null function. 0 dot a here is 0. Yes, this is and all. This is multiplication function, or is additional function. So 1 plus a here is 1, and this one a plus a here is a square actual algebra, but here is in case of logic gate a dot a here is 1. See, you can understand here in this case, you can understand, you just put if you are having any doubt, you just put a as 0 or 1 as an input. See, I just mentioned here in this case, I just put this value here, a is equal to 1. So if you put a is equal to 1 means 1 dot 1. So 1 dot 1 is 1. Again the same here is 1 plus 1. 1 plus 1 here is 11. Again you just add these together. 1 plus 1 here is 10 again. See here. I'm sorry. 1 plus 1 here is 10, and 0 plus 1 here is 1. So what you are getting here is a. So this is the concept. Suppose if you are having any doubt in this case, see here, any doubt in this case or this case, not a problem at all. You just substitute a here is 0 or 1. Only these two value. If you substitute this one, say for example in this case, if I put a equal to 0, 0 dot 1 here is 0. So a equal to 0 means what you are getting, that answer also a only, 0 only. The same one, if a equal to 0, if I put 0 plus 0, what you are getting here is a is 0. Suppose if you put 1, 0 plus 1 is 1. This is the concept. See here, in this case, if I put a equal to 1, so 0 dot 1 is 0 with multiply with anything is 0. See here, a equal to, if I put a equal to 0, anything you are adding with 1, what you are getting here is 1. 1 is on function in case of OR gate. This is AND gate, multiplication function. See, a dot a complement here is 0. How you are getting 0 here? See, for that what I am going to do here is simply you just put a equal to 1. See, simple concept. 1 1 complement here is 0. 1 dot 0 here is 0. Similar here, a equal to, I just put as 1. 1 plus 1 complement here is 0. 1 plus 0 is 1. That's a similar concept you need to add to understand better. See, this one also commutative law. AB, see here, AB is equal to BA, A plus B equal to B plus C. Associative law, see this one. Also, this is commutative law, associative law, and here you can understand here a plus b plus c. This one, a plus b plus c equal to a plus b plus c, and a plus bc here is, you just, this is about the simple factorization like this one, a plus b and a plus c. Simpler concept here, right? This is R function, and this one is AND function. So this one you need to remember. If you are having any doubt, you just put input value as a, say in this case I just assume, say a and b two functions are there. See, in this case I just mentioned here a and b, only two are there. A equal to 0 and b also I just put here as 0. See this one, 0 0 So here is this is 0, this is 0. 0 dot 0 is 0. 0 complement here is 1. So answer here is 1. So for that better understanding here, A and B I just mentioned here. 0 bar plus B also 0, 0 bar. 0 bar here is 1 and 0 bar here is 1. 1 plus 1 here is 10 and this one 0 and 1 add together you are having 1. So this is about the concept here, or even what you are getting here is the same one answer. So like this, you can easily check the formula. Next one, this is about NOR gate. NOR gate simple here is, I just mentioned here, OR gate, see here, OR gate plus NOT gate. See, OR gate we have already see, OR gate here is Y is equal to A plus B. See, simple concept that Boolean algebra, De Morgan's law, you just substitute here 0 plus 0. 0 plus 0 here is, see this one, 0. But this is not OR gate, this is NOR gate. NOR gate means OR gate plus NOT gate. OR gate answer here is 0 plus you are going to put a NOT gate here. NOT gate means this is complementary. This as a input will be given to NOT gate. So 0 here is 1. Next one similar concept here, 0 plus 1 here is 1. 1 complement. So 1 complement here is 0. Similar concept here, 1 plus 0 and 1 plus 1. So what you are going to have here is 1 plus 0 is 1, 1 plus 1 is 10, 10 here is 1, 0 here is 10, 1 plus 0 again, that is 1. So 1 complement here is 0, 1 complement here is 0. So in this case, what you are getting that output in all the case here, 1, 0, 0. This is the concept here. Right? Understand the concept. NOR gate means OR gate plus NOT gate. See, this is about the OR gate and this one here is NOT gate. According to this, you just put as an input here, substitute the value, you can get the corresponding output. Both X or gate, or even we call it as exclusively OR gate. This one I just tell you here. X or gate, the formula here is, see this one, both the input here, what you are given here is A and B as an input, A and B as an input. So here I just mentioned in this case of, in case of XOR gate here is AB. So A plus circle 1, so that is A bar B plus B bar A, or even we can mention here as A B bar plus B A bar. So this one according to commutative law you can understand here. So you can mention here A B bar or even A bar B. So in this case, see A bar B, see here I just mentioned here commutative law, A bar B or even B A bar, both are similar here. See according to this formula, see here I just mentioned the input, see here this one here is A and this one here is B, I just mentioned here. For this case A is 0, B also 0 here. So this one, this is the formula here. This is 0 plus this one also 0 here. I'm sorry. This one also I just mentioned as 0, right? So this one here is 0. So what you are going to mention here is 0 bar dot 0 plus again the same B bar here is again 0 bar dot 0. So 0 bar here is 1, 1 dot 0 plus 1 dot 0, 1 dot 0 here is 0, 1 dot 0 here is 0, 0 plus 0 here is again 0. So what you get the answer in this case, see 0, 0 as the input, what you are getting that output also 0. For this one you are going to use this one in this case. See I just mentioned here for this one. Again, see, you just put the input value in this formula, you can understand better here. 0 plus circle with 1. See here, A here is 0, B here is 1. So 0 complement dot 1 plus here is B here is 1, 1 complement dot 0. This one I am going to use here. With this, again I just mentioned in this case, 0 complement is 1, 1 dot 1 plus 1 complement is 0, 0 dot 0. What you are having here is 1 dot 1 is 1 plus 0 dot 0 is 0. So what you are getting here is 1. So this one, in this case, you just practice the third one, just practices. The fourth one I just mentioned here. See here, I just mentioned the fourth one here is 1 plus with circle again 1 here. So this one I just mentioned here, 1 bar dot 1 that is A here is 1, B also 1, A bar dot B plus B bar again 1 dot A. So 1 complement here is 0 dot 1 and 0 dot 1. 0 dot 1 here is 0 plus 0. So what you are getting here is 0. So this is the concept in case of the third answer. So this is about XOR gate. Now inside this XOR gate, inside what is there? What is the actual structure of this one? I just show you here how the XOR gate will be there. See, this is equal to this one. In this case here, A as an input, B bar. See, this is about AND gate A dot B, right? This one again AND gate, both output of AND gate will be given to the OR gate A B bar plus A bar B. See this one, the same concept. The first one is 0 0. I just applied here. See this one I just mentioned in this case. This is 0 and this one also 0 here. This is 0 as an input here is 0. 0 complement here is 1. So A B bar here is 0 and 1 bar. 1 bar again 0 here. So what you are getting that output here is 0. Right, so this one is 0 here. Similar concept. This one is A as an input. What you are getting here is 1 as a complement. This one is 0 here. So in this case, 1 bar, 1 bar 0. So 1 bar 0 is 0 0. 0 dot 0 here is 0. So what you are getting that answer here is 0. So similar concept. Now what you are going to use here is in the previous one 1 and 1. I just mentioned here both the input is 1. What you are getting that output here is 0. See this one I just mentioned here. So here, so this is 1 and this one also 1 here. So in this case I just mentioned as 1 and here is 1 complement here is 0. So this one, see here 1 0 bar, 1 0 bar here. See this one I just mentioned here again the same. See this case I just mentioned again. See 1 and 1 as an input. See simple I just mentioned here 1 and 1 as an input. In this case in a different color I just mentioned here 1 and 1. See this is 1 and this is 1 bar here is 0. So what you are getting here is A B bar, that is 1 1 bar. Next one here is see again the same. This also 1 here and 1 bar. This one, see here this is 1 bar and this one here is 0. So what you are getting this one here is again, see I just mentioned here sorry, this one also, I'm sorry, this one both are 1, right? See here also 1, here also 1 bar. See I just mentioned here this is A bar here is 1 bar and B here is 1. See from this one 1 dot 0 plus 0 dot 1. So what you are getting here is 1 dot 0 is 0, 0 plus 0 again same. What you are getting that answer here is 0. So this is the concept actually. Just go through, just substitute here and find out the value so that you can understand better this one. And about XOR gate. If you understand this one XOR gate, XNOT gate is quite interesting and too simple. Let me tell you the concept here. See in this case, I just mentioned here. Say for example, in case of XNOR gate, I just mentioned here. So this one XNOR gate is nothing but, see here XNOR gate. This is nothing but XOR gate plus NOT gate. Similar like a NAND gate or NOR gate, similar like this. I just mentioned here. NAND gate is nothing but what you mean by NAND gate? AND gate plus NOT gate. That is NAND gate. Similar like this. See here. This is about XOR gate. XOR gate plus NOT gate. That is XNOR gate. See this one in this case. What you are getting that answer in this case. See XOR gate answer here is, see what you are getting here is 0 1 1 0. Previous you can see here with this a complement here is, see you just going to add the complement of this one, that is 0 bar 1 bar 1 bar and even 0 bar. What you are getting that answer here is, that is about, I just mentioned in this side, that is 1 0 0 and 1. So that's what they have given in this case. You can see here they have given that answer, right? Okay, now so this one you can understand this one. See here I will show you in this case. See this is about, see what they have given here is, this is about XOR gate input. XOR gate input. The complementary of this one, you are going to have a XNOR gate. See for here XOR gate, see XOR gate I just mentioned here, that is A plus circle of B. That one value here is, see this one, A bar B plus B bar A. So this is the concept here. So this one you got the answer in this case. See what I'm going to have here is X NOR gate. X NOR gate is nothing but A plus NOT gate, right? NOT gate means complementary. So I just mentioned here A plus B whole bar. So this is the complement. Already you got the answer I just mentioned here. This one here is A bar B plus B bar A. This is XOR gate, whole complement that you are going to put a NOT gate. What you are getting that answer I just mentioned here. See this one, A bar B whole bar, and a plus will become dot here. See this one. If you put, I just mentioned here, if you put dot product on this bar means it will be converted into plus. If plus on, if you put a complement, that will become dot. See according to this you just understand here. See this one, the plus will become here dot. See next one, B bar A whole bar, right? See this one, same one I just mentioned here, A bar whole bar. See already this is dot, dot here is plus will become plus, dot will become plus here, and the dot is here. Next one, B bar whole bar plus A bar. See here you are having B bar here. See this one, B bar A bar whole bar. So A bar whole bar here is, see you can see the previous expression of this one, A plus B bar dot B plus A bar. Now substitute the value of this one. See first concept I just mentioned, A and B both are 0 here. So I just substitute here 0 comma 0 as an input. So this one 0 plus 0 bar dot 0 plus again 0 bar here. So what you are getting here is 0 plus 1 dot 0 plus 1. So what you are getting again here is 1 dot 1. What you are getting, that answer here is 1. So the first case answer here is 1. So that's, for example, the second one I will take it here. For the second concept I just mentioned, in this case 0 1. See first this one I just mentioned here. In this case 0 1. So answer here is A is 0 and B is 1. So 0 plus 1 bar dot A is 0, B is 1, and here is B is 1, A is 0, 0 bar. So I just mention again here, this one here is 0 plus 0 dot 1 plus 1. That is 1 plus 1 I just mentioned here. So 0 plus 0 is 0 dot 1 plus 1 is 1. So what you are getting here is 0. So similarly like this, you just substitute all the values over here and you can get this answer. Actually it will work under on this. So XOR gate is nothing but, XNOR gate is nothing but XOR gate plus NOT gate. Similar concept in the previous diagram, you just add with the NOT gate, you can get the answer. On to this, most important problems will be covered in next part. You just go through on this one. If you are having any doubts, see, specifically in semiconductor, such type of questions, one will be asked, that also easy questions. If you are having any doubt, you just share the link of the questions in comments. I just share you. Same I just include in the next session.